Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
In this problem, we have a current carrying wire supported horizontally by two posts, right, carrying some current I to the right, in this case here. And we know that the magnetic field that this wire is in makes an angle of 60 degrees with respect to the current. Now, we also know the magnitude of the force that is acting on this wire because of the current traveling through this magnetic field. Remember, currents are charges, so if charged particles are moving through a magnetic field, they experience a force. Now we have a new expression that gives us the magnitude of the magnetic force acting on a wire carrying current I when the wire is of length L, right? We need to remember we also know the length of this wire L, and we know the magnitude of the magnetic field, and then the angle between the direction of the current and the direction of the magnetic field. In this case, we're asked what is the magnitude of the magnetic field if we're given a particular force, magnetic force, that this wire feels. In this case, it's 0.15 newtons. So we want to know the magnitude of the magnetic field. We can solve for B then, and that gives us the equation of plugging in the magnitude of the magnetic force and then dividing by the value of the current, the length of the wire, and sine of the angle between the current direction and the magnetic field direction. Okay, then we're pretty much done. Just got to plug in everything. What is the value of the force that this wire feels? It's 0.15 newtons. The current it's carrying is 75 amps. The length of the wire is 45 meters. And the angle between the magnetic field and the wire is 60 degrees. We plug all of this in, and we see we get an answer of the magnitude of the magnetic field through which this current is traveling is 5.1 times 10 to the negative 5 teslas.